Alright, so this question says we have a gx which is nothing but greatest integer function of x. And we have another function f of x which is equal to gx square minus gx. We need to figure out this function fx is discontinuous at what all values. Alright, so what we will do is we'll first create f of x, right? Let's do in the next page, next slide, whatever you call it. Okay, f of x would be equal to what, you tell me? GIF of x square minus GIF of x, right? Now we already know one thing, that if I talk about individually about this greatest integer function of x, bracketed x, we call it those two, both the things, greatest integer function or bracketed x, right? So, okay, if this function, if I talk about this function individually, this function is discontinuous at all integers. That means if I talk about fx, we need to check for all integers, right? To check for all integers, let us mark this x as I. Capital I is an integer. So what we need to do is we need to check for f of I minus, f of I and f of I plus. If all the three values are same at that time, then the function is continuous. If not, at that point, function is not continuous or discontinuous. Let's talk about f of I first, right? So I integer square minus integer GIF. Okay, right? Just replace x by capital I, which is an integer, right? Now GIF of any integer is always an integer, right? There is a square and this is again I. This is f of I. What about f of I plus? So I plus square and I plus inside this GIF, right? Now I plus. GIF of I plus would be nothing but simply I. So this would be I square minus I. Okay, so far so good. These two are equal. What about f of I minus? Let's check it out. So I minus whole square and I minus again. Cool. Now GIF of I minus, if I talk about GIF of I minus, it is nothing but I minus 1. Let me show you how. So if you talk about GIF of 3 minus, right? 3 minus is what, you tell me? 2 point something. And GIF is nothing but what? 2. Right? So this is I minus and answer is what? I minus 1. Right? 3 minus, result is what? 2. 4 minus, the result is what? 3. That means I minus, the result is what? I minus 1. Right? So this is I minus 1, free from GIF this time. And here we have again I minus 1. Right? If you solve it, what do you get? I minus 1 multiply I minus 2. Now, you tell me that f of I minus is a completely different thing. F of I minus is completely different thing, isn't it? This and this. LHL and RHL are not equal, right? But wait, I cannot definitely say that LHL and RHL are not equal because I have one case. Yes, tell me, I have one case. See, if I is equal to 1, then what is happening? If I is equal to 1, then what is happening? You tell me. If I is equal to 1, then this f of I plus, or we can say f of 1 plus, would be equal to what? 1 square minus 1, that is equal to 0, isn't it? And again, same thing, f of 1 would be exactly same, 1 square minus 1 is equals to 0. And in fact, f of 1 minus, if I evaluate from this definition, what do I get? I get 1 minus 1, right? And then 1 minus 2, that is a negative 1. That means overall I am having 0. That means f of 1 plus, f of 1 and f of 1 minus are all equal, right? That means the only integer at which this fx is continuous is nothing but what? Is nothing but x equal to 1, right? So let's just understand it again. Let's just understand this one point again. At x equal to 1, what is happening? So we all know this is our fx, plugging in the value. Right now, we know that greatest integer function is discontinuous at all integers. That's why we are checking only integers. So we have already checked that f of I plus and f of I minus have two different expressions. F of I plus is nothing but I square minus I, but this is I minus 1, I minus 2. And same goes with f of I, right? Both are having I square minus I value, right? Now these two expression are completely different expression, but they will attain same value at x equal to 1, right? So let's just talk about f of 1, f of 1 plus, f of 1 minus. So f of x can be discontinuous at every integer. That is our assumption. We are just checking. So if I talk about limit x tend to 1 minus, what do I get? I get 0, because 1 minus is what? 0, and 1 minus is again 0. And then what about 1 plus? At 1 plus, what do I get? I get again 1 minus 1, that is what? 0, right? So limit exists, and of course f of 1 is also 0, right? So LHL, RHL and f of 1 all are 0. So this function is continuous at x equal to 1, but discontinuous at every integer. So overall, the last final statement is the function is discontinuous at every integer except x equal to 1. So here the answer would be what? Clearly option B. Got it? Alright, so in this question, it is given that fx is equal to k when x is equal to 2, and fx is equal to this big fat expression when x is not equal to 2. It is also given that this function fx is continuous from right at the point x equal to 2. Then we need to figure out the value of k. Now, what does that mean? Continuous from right at the point x equal to 2. Now, the basic definition of continuity is what? LHL equal to f of a is equals to RHL. If I talk about continuity at x equal to a. But when it is already said that continuity from right at the point x equal to 2, that means only this thing is happening. F of 2 is equal to RHL, that's it. There is no role of LHL in this question. Got it? Okay, if you got it, then let's start the question. Let's start solving the question. So we already know that f of 2 is equal to RHL. RHL is nothing but limit of fx where x is tending towards 2 plus, right? 2 plus means x is greater than 2, not 2, right? Not 2 means this particular expression. Let's copy this expression as it is. So we have what? Limit of x square plus e raised to power 1 by 2 minus x whole raised to power minus 1, x tending to 2 plus, right? If you evaluate this limit, what do you get? You get, okay, 2 square, then you have e raised to power 1 upon 2 minus 2 plus, right? And this raised to power minus 1, of course this is 2 plus whole square, right? Now you tell me 2 minus 2 plus is what? 2 minus 2 plus, here 2 plus is here, right? 2 minus 2 plus is nothing but 2 minus 2 point something, right? So this is nothing but negative of some fraction, smallest fraction, right? So this is nothing but 0 minus, right? So if I talk about 2 minus 2 plus, in the next step I'll be writing it as 2 plus whole square plus e raised to power 1 upon 0 minus and raised to power minus 1. So our expression f of 2 would be equal to what? This would be 4 if I apply the approximation, because we are calculating the limiting value. And here we have plus e raised to power minus infinity raised to power minus 1. Now e raised to power minus infinity is what? 0, right? E raised to power minus infinity is 1 by e raised to power infinity is 1 by infinity, that is equal to what? 0. All this is tending. Cool. So this is nothing but 4 raised to power minus 1. That means f of 2 is nothing but what? F of 2 is nothing but 1 by 4. But in here f of 2 is given as k. So that means k equal to 1 by 4. Yes. One thing I would like to give stress upon, the point of mistake. What is the point of mistake? Where can we do the mistake in this question? All right. So here can you see the moment you plug in x equal to 2, if you directly start plugging in x equal to 2, you get 2 minus 2, you see 1 by 0. Okay, 1 by 0 is e raised to power infinity. So some students might think that this is nothing but e raised to power infinity, which is wrong, right? Which is incorrect. Are you getting my point? So this part where you put exact 2 minus 2 plus, right? Replace x by 2 plus. Then you see what is happening. Then if there is a need of doing the approximation, taking x equal to 2, then go ahead. But first thing, please try to do please try to put the values as it is, 2 plus 2 minus, whatever it is, right? So in this question, k is equals to 1 by 4. So option B is absolutely right. Got it? All right. So in this question, a function f of x is given to us, and we need to figure out whether this function is continuous at x equal to 1 or not defined at x equal to 1. Whether this function is discontinuous at x equal to 0 or not defined at x equal to 0. That means we need to check for x equal to 1 and 0 both. All right. So this is your function, right? And so if I modify this function, can I write this function as x minus, now this is what you tell me, this is nothing but modulus of x, and then we have 1 minus x, and then modulus closed, right? So this can be written as x minus, now this can be rewritten as modulus x, modulus 1 minus x, by using property of modulus, just like this. Yes, we can do that. Okay, now let's define this whole function. Let's try to define f of x, right? So can you see there are two modulus involved? Can you see? Yes, there are two modulus involved, right? If two modulus are involved, two critical points would be there. So first one would be x equal to 0 and second one would be x equal to 1, right? So I'll be actually taking this whole f of x, I'll be defining it piecewise. First one would be what? X less than 0. Right, x less than 0. Second one would be what? Okay, so 0 then 1, right? So x greater than 0 but less than 1, right? And last but not the least, x greater than or equal to 1, right? So equality has been applied only once. Now you tell me, when x is negative, then this would be modulus x would be what? Modulus x would be minus x when x is negative, right? And what about 1 minus x? So when x is negative, then what will happen is this 1 minus x would still be positive. So 1 minus x this time is what? Same 1 minus x. So if I try to put it over here, f of x would be equal to what? F of x would be equal to x plus x times 1 minus x. So when x is greater than or equal to 0, then again this modulus x will be what? This time plus x, right? So x minus x, and then what about 1 minus x? So when the x is between 0 and 1, right, this 1 minus x will still be positive. So this is 1 minus x. And last thing, here we have what? Same x, and then x greater than or equal to 1. That means modulus x will still be positive, but 1 minus x will get opened with a negative sign. Yes. So over here, this is your f of x. Can you see? This is your f of x. If you rewrite your f of x, it will look like this. See, x less than 0, we have x plus x times 1 minus x. For x between 0 and 1, we have x minus x times 1 minus x. And for x greater than or equal to 1, x plus x times 1 minus x. Can you see? For these two intervals, we have same f of x. But for 0 including to 1, we have this f of x, right? Sorted. Now, we all know that we need to check for, as per the question, we need to check for at x equal to 0, at x equal to 1. Let's start with x equal to 1, right? So first of all, we are checking the continuity, right? And we are checking whether function is defined at x equal to 1 or not. So let's find out f of 1 over here. All right, so f of 1 we need to evaluate. For f of 1, we need to go over here, right? So this would be nothing but 1 plus 1 times 1 minus 1. So this is equal to 1. F of 1 is clearly equal to 1. Let's now talk about f of 1 minus. For 1 minus, I need to look for any interval which is less than 1, x less than 1. That means this, right? So this would be nothing but limit of f of x, where x is tending towards 1 minus, right? So this is, let's replace fx by this. So limit of x tend to 1 minus x, 1 minus x. And once I put the values, what do I get? 1 minus 1 times 1 minus 1. So this is nothing but 1. Last, we need to talk for f of 1 plus. Can you see, for f of 1 plus, we are going to get the same value. Yes, f of 1 and f of 1 plus are going to be exactly same, because you'll use this expression. And again, you'll put 1. So you have what? 1 plus 1 multiplies 0. So that is nothing but 1. Right? So can you see, at x equal to 1, this function is continuous. this function is continuous at x equal to 1 because LHL, RHL, function value at x equal to 1 are exactly same. Alright, so now you know the drill. Now let's just talk about x equal to 0 in similar manner, right? So at x equal to 0, what is happening? Let's first calculate f of 0. F of 0, we have to go here. 0 minus 0 times 1 minus 0. So f of 0 is 0. What about f of 0 plus? For f of 0 plus, we need to go again here. In fact, f of 0 plus and f of 0 would be one and same thing. If I talk about f of 0 minus, that means this particular expression, limit of f of x, where x is tending towards 0 minus, would be equal to what? This expression I need to replace by f of x. So this we have done so many times, right? X plus x times 1 minus x. The moment you plug in the value, then you'll get a 0. That means the function is continuous at doubtful points which are x equal to 0 and 1 both. The function is continuous, right? So function is continuous everywhere. Can you see? Because these two were the only doubtful points. Except these 2 points, we already knew that function is continuous. And at 0 and 1, we have proved that function is continuous. So that means overall now the function is continuous, right? So option A matches that it is indeed continuous. Option B says discontinuous. No, 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 it's not right. Not defined, it's not right. Option D is also not right. So only option A for this particular question is the right answer. Got it? Alright, so here we have a function f of x which is equal to this whole big fat expression where x is not equal to 0, and this function is equal to a when x is equal to 0. As per the question, this whole function is continuous in this interval, that is 0 close to 1 close. We need to figure out the value of a. Alright, so here this time what is happening again, the function is continuous in the interval. So by observation, we need to determine at what all points we should make it continuous. So first of all, the function is breaking at x equal to 0. Do you agree? The function is breaking at x equal to 0, isn't it? That means we need to make it continuous at x equal to 0 first of all, but over here, can you see this is 0 onwards, 0 and 0 onwards. That means to make it continuous, I don't need to use the whole definition. This is the whole definition of continuity, right? For a function to be continuous at x equal to 0, in general, what do we use this? But this time, what we are going to use is nothing but this. What is this? LHL. No, we are not talking about LHL, but we are talking about RHL because here in this interval 0 minus doesn't exist, right? So RHL should be equal to f of 0. That we need to keep in mind. That's all. Alright, if this is sorted, if you understand this, then let's proceed for continuity in 0 close to 1 close. F of 0 should be equal to f of 0 plus, right? Only this. No need of 0 minus because in this interval 0 minus doesn't even exist, right? So f of 0, what is f of 0? You tell me. F of 0 is a. F of 0 plus, that we need to figure out, right? F of 0 plus would be nothing but limit of f of x where x is tending towards 0 plus. For 0 plus, we need to replace fx by this whole huge expression just like this, right? And we need to evaluate it. This indeed is equal to a. So this would be what? We need to evaluate this limit of this expression when x is tending towards 0 plus, right? Once this limit is sorted, that would be the value of a, right? So let's get started. Okay, cool. All right, so here, can you see this is sine cube root x? Yes. So this would be nothing but limit x tend to 0 plus sine root x whole cube. Now what do I need in denominator? Because I want to use the standard limit sine x by x is equal to 1 when x is tending towards 0. So I need root x whole cube, right? Okay, all right. Log 1 plus 3x I have. Again, I can use a standard limit. What is that limit? 1 plus log x. Okay, log 1 plus x by x. That will be tending towards 0, right? Okay, all right. Now we have tan inverse root x. So can I write it as tan inverse root x? And of course, we have a square. I need root x square as well. And last but not the least, I have what? Okay, let us write it in short. Okay, I have log 1 plus 3x by 3x, and then I have tan inverse root x whole square by root x whole square, and then I have, yes, last we have e raised to power 5 root x minus 1, right? And then I need what? 5 root x, because again we are going to use standard limits, and then we have x over here. Now see, I have multiplied so many factors, so I need to compensate this as well. This will be get multiplied over here, root x cube. This will get divided, okay, this will also get multiplied, so I have 3x with me, and then I need to divide by root x square, and of course I need to divide by 5 root x. All right, okay, cool. Now let's see what is happening over here. This thing is tending towards 1. Why? Because we know that limit sin x by x, where x is tending towards 0, is nothing but 1, right? So this is 1. What about this? This is again log 1 plus x by x, where x is tending towards 0 is 1, so this is also 1, right? Again same thing, tan inverse x by x, tan inverse some quantity whole upon that same quantity is also what? Tending towards, is also equal to 1 when x is tending towards 0. All right, this is also 1, this is also 1. We are actually left with so many x. Let's calculate how many x are left. So this is root x cube. Root x cube is nothing but x root x, sorted. Then we have 3x. Then we have an x already in the denominator. Then I have root x square, that means this is x. And then we have 5 root x. So I have x gone, all the x gone here actually, and 3 by 5. So 3 by 5. So A is clearly 3 by 5. We've got the answer. A is equals to 3 by 5, which is matching with option B. Alright, so we have a function which says limit of x multiply GIF of 4 by x is equal to A when x is tending towards 0, right? So by solving this limit, we can easily figure out what is the exact value of A. Alright, cool. Then we need to figure out that if we have a function f of x, which is nothing but GIF of x square multiply sine pi x. And this function is discontinuous at what all points, and that points are given in terms of A, right? So that means first thing we need to figure out what? A. Okay, so if I first talk about this f of x a little bit and then talk about this limit, then it's fine. Okay, so fx, if we see this fx, if we realize one thing, that if x is an integer, then this sine pi x is what? Sine pi x would be equal to 0, because sine integral multiple of pi is 0. That means if x is an integer, then there is no problem. So first thing, that fx is continuous for all values of x belongs to integer, because sine pi of that integer in the neighborhood of that integer also is equal to 0, right? So at that integer it is 0, after that integer it is 0, left side of that integer it is 0, so that means it is continuous, right? But okay, so what all points it can be discontinuous, that we need to figure out. So first of all, this is what GIF of x square, right? GIF of x square is discontinuous when the output, actually when the input of GIF is what? Integer. That means if x square is an integer, then the function can be what? Discontinuous. That means the function will be discontinuous when x square is an integer. But we have an exception, that when x is an integer, this is continuous. Okay, two things. At one time, two things are going on. I'll list one by one. When x is an integer, it is continuous. But when x square is an integer, it is discontinuous, right? What does that mean? Let's understand, right? So fx is discontinuous at point where x square is discontinuous. GIF of x square is discontinuous. That is, x square belongs to an integer, with an exception that fx is continuous when x is an integer. That means what all points? That means if x is equal to 1, it is continuous. X is equal to 2, it is continuous, right? But when x is equal to root 2, then what will happen? X square will be still an integer, and at this point our function would be discontinuous. Yes, so points of discontinuity now you know would be what? Plus minus root 2, plus minus root 3, plus minus root 5, and so on. Not plus minus root 4, because eventually it will become what? plus minus 2. 2 is an integer. X is equal to 2. That means it will be continuous. Okay, alright. So that was all about the f of x. Let's get back to this limit part, right? Okay, so this is given in the question that limit of x multiplied GIF of 4 by x is equal to a. Right? If you carefully observe, this is 0 multiply 4 by 0. 4 by 0 would be what? Infinity. 0 multiply infinity form. So we need to modify this form. We need to actually modify. So GIF, you know, GIF of x would be equal to x minus fractional part of x, isn't it? So can I write this 4 by x GIF as 4 by x minus fractional part of 4 by x? Yes, of course. If I do that, our limit will look like this, right? Our limit is looking like this right now. If I multiply this x, then what do I get? X multiply 4 by x minus x multiply fractional part of 4 by x. This x is gone. So we are left with 4 minus x multiply fractional part of 4 by x, right? Now this x is what? Tending towards 0. So this whole thing is gone. A is exactly equal to 4. That means the limit of this particular expression is nothing but what? 4. A is equal to 4. Now we've got the value of A, and if I talk about all 4 options, if I list all 4 options right here right now, my all 4 options will look like this. Root A plus 5 is one of the options. If I plug in the value of A, so what do I get? 4 plus 5 and a square root. That means 3. At 3, you tell me our function f of x is discontinuous or not. We have already figured out the point of discontinuity would be what? Square root of some expression, which is not a perfect square. Square root of 2, square root of 3, and of course plus minus sign. So this is not correct. This option is incorrect. Let's talk about next, which is what? Square root of a plus 1. You plug in. So 4 plus 1 is equals to root 5. Yes, this is our option. This is our answer, right? Because at root 5, our function is discontinuous. We are looking for points of discontinuity. What about next option, which is a plus 21 whole root? So we need to plug in. So this would be what? Root 25. That would be what? 5. Again, not our answer because 5 is an integer. At all integers, it is continuous. But at all square root of some not perfect square quantity plus minus of that values, this is discontinuous, right? We are looking for points of discontinuity. And last but not the least, square root of a. Square root of a, that means square root of 4, that is equal to 2. Again, no, not a big no. So only square root of a plus 1 would be our answer, which is exactly matching with option A. Got it?